Right, good day and welcome. Now we're looking at Theorem 7. A, if a tangent drawn to a circle is drawn, then it's perpendicular to the radius. The point of contact on short tangent will always be perpendicular to radius. It's not the example proof, but still we'll do it. Given circle with center O, the radius OA, their tangent TA touching the circle at A. Required to prove that OA perpendicular to TA. So construction, first I draw the line OP, right? So OP is drawn in such a way that it touches the tangent on the outside of the circle, therefore it's not a radii or radius, right? So by assumption we will assume that the shortest distance from a point to a line is the perpendicular distance. So the shortest distance is the one must have a 90 degree. So A is the only point on the circle and the tangent, while P lies outside the circle. So OA, therefore, must be smaller than OP, right? Because that lies outside the circle and that is inside the circle. So if OA is smaller than the length of any other line segment from O to a point on TA, other than A, then OA is definitely considered the shortest distance from O to TA, right? And therefore, by assumption now, we can say that OA is perpendicular to TA 90 degrees, because we assume that the shortest distance from a point to line is perpendicular distance, right? It's not a proof that you need to know for exam, but I'm just showing the formal proof for Theorem 7a, right? If you look at proof 7b, this one in exam we will test, and you'll have to prove to us that the line is a tangent. So if a line is drawn perpendicular to a radius at the point where the radius meets the circle, then it is a tangent to the circle. So there, right, line perpendicular to radius. So given circle with center O, a radius OA, and TA perpendicular to OA, meaning they meet at 90 at A, required to prove that AB is a tangent to circle O. So construction, first we draw OB. Oberon Sherry, I'm just joking, we draw OB. Right, OAB equal 90 degrees, right? Straight angle, angles on the straight line. That's if that's perpendicular that side, this must also be 90, because 90 plus 90 must give me 180. Right? So we should know that OB is greater than OA, the hypotenuse of the triangle. So opposite the 90 degrees, OB is the longer side. But B must lie outside the circle since OA is a radius. So angle P is outside the circle, not inside the circle, because OAI a radii and OB is longer than the radii. Therefore, TB intersects the circle in only one point, namely A, and therefore now TB is considered to be a tangent to the circle at P, or there we're at P, right? And as I said, this will be